This is Hati, a 3D platformer about a wolf from Norse mythology. As the price for having been born as the son of Fenrir, Hati is doomed by Odin to forever chase the moon across the sky. Having whiled away my free time for too long, it's time for me to give back to the gaming space. I've started with nothing but a blank Unity scene, and asset by asset, line of code by line of code, I seek to build the best video game a rookie indie dev can. Cameras. Fuck 'em. The goal for this episode is to further refine the wall movement system for Hati, focusing specifically on camera movements. However, the first thing that needs to be addressed for this episode are some new animations I've worked on. Well, some new old animations at least. To my surprise, I created a peeing animation, a howl animation, a shake animation, and a hang animation 3 months ago now. 2 of these are in my intro, but I think the peeing one might be my favorite. During the beginning of December, I worked on some logos for Hati. I'm pretty happy with the ones I ended up using, which are shown at the beginning and end of my YouTube videos. And they work in color as well as in black and white. I originally had made a substantially different font, but when people pointed out it was more horror than Nordic, I turned it into what you see now. As promised at the end of the last Devlog, I got to work on the camera. I created a list of 5 things I wanted to address first, loosely categorized in order of assumed difficulty. The first thing on my list is to Dutch the hang state relative to the direction of the camera, which should cause it to be more at the sides and less in the middle. This should create a smoother transition between hang and horizontal state, which always Dutches the camera to the same place. It was a remarkably simple implementation that just uses a basic calculation to set the camera Dutch target value. I'd wanted an easy win since I hadn't coded in so long, and thankfully I got one. Time for number 2. And not the type of number 2 that you're thinking about in your dirty mind. In devlog number 1, somebody left a very helpful suggestion to transition to using Unity's new input system. I originally avoided it because in many forum posts, people were bemoaning its complexity. But in actuality, while it's a bit more legwork to set up, it saves a lot of time in the long run. Unfortunately, my current code structure doesn't adhere to the new input system's preferred event-based architecture. I could spend days refactoring all of my code, but it isn't worth it to me for the probably very minor performance boost. So instead, I found equivalents to the old system's formula and replaced the relevant lines of code. Also, I've been working on this game for 1.5 years now. Fur is hard, okay? I encountered 2 problems after my large refactor. One of these was state switch checks where I'd incorrectly converted my code. These were annoying but easy enough to track down. The other was harder. I found I couldn't control my basic free roam camera. For some reason, the camera package I'm using, Cinemachine, no longer tolerated max speed as an input format. And instead, I had to switch to input value gain. I have no idea why this was necessary, but if it works, it works. My movement was now in a somewhat imperfect state, which can only mean one thing in the holo development cycle. Time to work on something new! Third on my list was to change the input for wall running. Up until now, if you wanted to run left on the wall, you had to hold D, and if you wanted to run right, you had to hold A. These are kind of in the opposite order you'd first think, primarily because you need the opposite side's keys free to leave the wall if you want to. Instead of this system, I think I'm going to use Q and E. This should provide a clear differentiation between what is wall running and what is moving left or right in the player's mind. Better yet, using a different key means that on a gamepad you can use triggers to hold onto the wall, which seems very intuitive to me. Number 4 on my list was handling the camera aim when leaving the wall. The problem was simple enough. The wall state would end, which would reset the wall camera, which would cause a jarring effect during the transition from the wall camera to the free roam camera. The forward dash state was the worst with this, so I started there. I'd already done some work to make it function with wall states, but after adding in the new input system, the camera didn't work at all during this state. It's also the case that the wall horizontal state snaps to Hati's direction for some reason. I'd figured all of this was probably going to require a lot of investigation. Soon enough, I'd fixed it. It turned out that the method for clamping the camera was the cause of the jerky rotations. Why this had sprouted up during my refactoring for the new input system, I'm not sure. But I'd probably simplified the clamp numbers at some point, not realizing the true purpose for the way they were. Going back to the forward dash state, I started by using my greater depth of coding experience to simplify the functions and the general flow through the state. I also decided to slightly change how the dash state functions. It used to be the case that the player can turn their character while dashing by moving the camera, but it is no longer. I think this will create more interesting gameplay, because while being more restrictive, it will have the benefit of forcing experienced players to be careful with where they dash, and also have the benefit of preventing inexperienced players from accidentally sending themselves off an edge. As I started improving dashing on walls, I found that I needed to make use of math skills I haven't used since high school geometry. My first idea for determining the dash direction was to take the angle of the camera relative to the wall and use some good old trig to determine the direction on the wall. This almost worked, but ultimately the direction was almost always slightly off where the camera was actually facing. At this point I figured, I know the direction the camera is looking, and I have all sorts of information about the wall, so why can't I just map the camera look vector onto the wall? Lo and behold, I can. Ladies and gentlemen, I present to you Project on Plane. It's very, very complicated. It takes a vector and it projects it on a plane. Unfortunately, while finding the dash direction was the most interesting part, it wasn't the easiest. I spent a long time locking certain objects to an orientation, blending objects, ensuring a smooth transition out of the state. This part was the majority of the work, and afterwards all that was left were finishing touches. I smoothed the camera damp values, the Dutch values, and the FOV from their normal state to the dash state and back again to prevent any jitteriness and add a little flair. Now that the forward dash state works with the wall states, we can finally return to the original task. I removed a few transition functions that were outdated, and suddenly there's no more jarring transition. Item number 4 really should have just been to handle the forward dash state on the wall, because that's all it ended up being. Finally, it was time to move on to item number 5, reducing motion sickness during camera movements. There are some things that I know that I want this game to be, and they come with necessary sacrifices. When researching other 3D platformers, I found a common complaint among players was the less than optimal camera systems. My vision for my game involves very dynamic movement within the confines of levels that are extremely dense and involve loads of verticality. To facilitate these systems and provide maximum amount of enjoyment for the player will require an equally dynamic camera. Therefore, my priorities for the camera are as follows. 1. The player will always have a meaningful degree of freedom in positioning the camera. 2. A player who's paying attention should never lose track of what's happening on screen. 3. The camera will always follow Hati directly to help sell the energy of the movements. 4. Within these constraints, the camera will do everything that it can to reduce motion sickness. This does present at least one obvious problem from a game design perspective, but that will be for future Hello to manage. With that in mind, let's explain the system I started with. For every camera transition, there's a start and an end rotation for the camera. The start rotation is exactly as it sounds and can be anywhere within the player's rotational rectangle of movement. With the exception of the hang state, the end rotation is a predetermined value depending on the state being transitioned to. For most camera transitions, there's also an in-between rotation that is moved to in order to make the movement more fluid. When this transition happens, all camera values, including clamp values, local rotations, and world rotations, are gradually shifted to the new destination. This system is largely functional, except for 2 rotations that act like problem children. Like me, that is. This is where our first restructuring starts. I altered it so that the camera aim's world rotational values are directly changed to transition to the new location, and all other necessary values are set at the beginning. This not only simplified code, but probably marginally improved performance. However, it revealed a problem. For every given state, the speed of the camera reset is inconsistent. If the player chooses to have the camera rotated far away from the reset destination, it will travel much faster than if the player's camera is close to the destination. To solve this, I created a function that calculates the angle between the start and end rotations, and then sets the time for the camera to reset accordingly. It was then that I encountered whatever this is. While transitioning out of my old camera system, I saw the backflip state from a non-forced perspective, and it's really inspired me to create custom wall jump animations for each state. But not yet. We still have more work to do on making the cameras functional. However, it was extremely rare in this process that I was able to work on the thing I actually wanted to work on. And following that trend, the next thing I did was make it so that when transitioning to the horizontal run state, the camera resets slightly away from the wall, like with the run up and run down states. Eventually, I managed to change the transitions for each state to use the absolute rotation value of the camera. But I came to a frustrating truth.
That's not good enough!
The transition either way between horizontal state and run down state was the biggest problem, and for all my effort, even just the reset rotations sometimes clipped with the wall. Never mind where the players chose to look. I think nothing encapsulates my struggle as much as this block of code, which basically says, depending on the angle of the camera, set the in-between rotation to between these 2 rotations. This implementation is kinda like, whatever happens, happens. And as we know,
That's not good enough!
I believe the fundamental problem with this system is that Unity's rotational system works on world axes, and the walls in question have their own local rotations. That means for the second time in this video, I'm gonna have to heavily overhaul my camera system. My first plan was a little weird. The linchpin of this operation is to make sure that the camera first and foremost rotates around the wall normal. I thought that if I calculated the other 2 rotations around the up and forward, and then rotated them simultaneously, I ought to get a seamless movement. Unfortunately, this ended up looking extremely messy, so instead I rotated around the camera's own start X rotation and the camera's forward vector for the up and down and twist respectively. Preliminary results were not looking very promising, but I kept at it, and I kept at it until eventually I got the results I was looking for. The only thing left for me to do was to handle the transition from run down to hang state. For the other 2 states, nothing special was required, but for run down, the camera was required to rotate at least 90 degrees, but usually closer to 180. My first plan to handle this, which I coded but didn't record for some reason, was to let the camera stay looking down and then flip it if it moved beyond a certain threshold. This created issues as I either had to eliminate player input during the transition or reverse it, and both options felt bad to use. Instead, I just made the run down state the only one that has a reset when transitioning to the hang state. It's kept as minimal as possible, such that when the camera resets, the player will be looking the same direction as they were when running down the wall, and thus, my camera system is once again functional. When working on the first 5 items, I'd added a 6th item to my list. Hati is currently capable of running on a wall that has a greater than 90-degree angle, and while I don't mind this, the wall run bar should absolutely drain faster as a result. Changing this was pretty quick. Just needed to use some trig to find the angle of the wall, and then use that number to calculate a new wall run timer multiplier. The final thing I worked on this month was creating a new backflip animation. Unfortunately, this exposed weak spots in my rig, and I ended up spending a day fixing various issues, such as the rear legs twisting with the root control, the twist on the neck flipping, and creating a space switch for the shoulders. Once I did that, I blocked out the basic movement 3 times. Why 3 times? Well, the first 2, I didn't realize that Maya's references relied on namespaces. And I decided I didn't want to stare at ugly namespaces when there's only really one object in the scene. So I removed them at the beginning twice. The first time, I figured it was a fluke or a corrupted file, so it only became clear to me after I saved and reopened it the second time that there was a deeper issue. An issue with my fucking brain. In my first pass, I actually didn't make it past the basic blocking, as I didn't like the result, so I actually ended up blocking for a 4th time. I think I was so frustrated from having already done it twice that I wasn't able to put my best work forward. I was quickly running out of time for the month, and I wanted to take care of the backflip state for good, so I rushed out the rest of the animation, and it's okay. It will definitely need some help for next time, and there are a few areas I think I can work on to quickly make it better. However, that was my progress for January 14th to February 4th, 2024. Hope you guys enjoyed watching. Please subscribe if you did. I'm planning for my next video to be about finishing up the animations and polishing the details of my movement system, including some particle physics. Going over it in my head right now though, it may take me 2 months to finish it. The video after that will hopefully be about creating IK systems for Hati's paws to match the ground, as well as joint manipulation for more naturalistic movement. And perhaps after that, it will finally be time for real level design. Anyway, with that having been said, until next time, live well. I smoothed the camera damp values, the Dutch values, and the FOV from their normal. I smoothed the camera damp values and the Dutch values from their. I smoothed the camera damp values and the Dutch value. I smoothed the camera damp values, the Dutch values, and the FOV from their normal state to the wall dash state and back again to prevent. I smoothed the camera damp values and the Dutch values back. I smoothed the camera damp. I smoothed